crypto in general has a problem. We have these booms and busts because nothing is really sustainable. Most projects are coming and going in 6 months, right? We need a foundation, a financial substrate where on top of which we can build long-lasting sustainable protocols on the yield of Ethereum validators. So as long as the chain keeps moving ahead, we will have that yield and we'll be able to build a flourishing industry. And we need the validators to secure the network, and we need the users to be able to participate in the Ethereum economy without getting constantly wrecked. Wherever they go, they're getting sandwich, front run, back run. We need to, stop that. We need to build an open, build a marketplace in an open MEV supply chain. And when we achieve that, we'll be in a much better place, and we'll be closer to the original vision, I hope, of Ethereum. My name is Vincent. I'm heading the engineering at Blockswap. That sort of entails the Stakehouse protocol, proof of neutrality, gateway, Blockswap Cloud, sort of, anything to do with the engineering side of things, bringing the vision of the company to life. Across the different protocols that are being produced, they all follow the very similar sort of guiding principles, follow similar sort of like patterns, and use technology that has been built in-house over 4 or more years of research and development. So, Blockswap Labs, the core contributors to the Blockswap network, are heavily research focused. The main areas of the research has been around sort of registries, how you can leverage registries inside of Ethereum, one of the most congested and highly used networks in the blockchain space, how we can leverage it to do more off-chain while still having on-chain settlement guarantees. The idea behind the registries is that you can precisely query what assets you own in isolation from everybody else. That's very different from a pool model, which is very common in DeFi at the moment. And that is definitely changing as we transition out of a pool model, which requires constantly poking the contracts. It requires to update them on stake, move from contract to contract as people are searching yield and doing whatever they're doing inside of DeFi or NFTs and stuff like that. So move into more sort of registry and intent-based models where users know exactly what assets they own. It's not mixed in a big pool with other users, and they are still achieving their goals, really. So registries are definitely at the core of that, and are giving the same levels of guarantees that users are expecting today. So, for example, the Stakehouse protocol is definitely a sort of a platform that people are building on top of. It is the same for the proof of neutrality network. So it's these base set of contracts that give users the base primitives that they need to build their own protocols on top. So Stakehouse, for example, it provides the base for users to create their own LSD networks on top of the Stakehouse protocol and earn commission from the networks that they run, which is just one use case for leveraging the programmable yield inside of Stakehouse. So specifically about the base protocol, the base smart contracts, the idea is to make them as small as possible, as easy to interface with, but also using formal methods to try and get some level of assurance that when people are building on top of the smart contracts, that they have some kind of idea on what is the behavior of the underlying system, especially when you start to add additional functionality on top of that. The formal methods, they start very early on in the product development lifecycle. So putting together, a specification in English on what are the expected behaviors of the system, translating that into formal models, with mathematical notation, and then proceeding to an implementation. And it really doesn't matter internally like how many variations or implementations of the specification there are, so long as when we use formal tools, we're trying to leverage, for example, Foundry to write property tests, invariant tests, so that we can plug it into tools like KEVM. And we use a combination of tools. We've used Satora in the past to get to a level where we can say, right, well, we have some expected behaviors of the system. Does the implementation conform to that specification? So that you as builder know that when you're building on top, what is actually happening. And the goal in hopefully the not too distant future would be for people to say like, so right now, if a user is interacting with an instance of a contract, maybe it's an instance deployed from some kind of factory, they might want to know, okay, well, I might not know what this contract is, but as long as it behaves in a certain way, I can reason about what's going to happen to my money. Sharing proofs that the specification holds, and then people can say, okay, well, I'll take that proof and I'll run it against the contract and say, okay, does the contract work as expected? Formal side of things is really important for giving some assurances on how the base platform is working, whether it be Stakehouse protocol, proof of neutrality, gateway. We're exposing these primitives. They're not the end protocols as you suggested, so they are for people to take and build on top of and add business logic. What we're trying to do with, like, for example, with the gateway is basically say, if you want to use state or balances as a type of state, if you want to use that in a multi-domain context, how do you do that while still preserving the double spend problem, which is what obviously Bitcoin solved in the first place with its blockchain technology. It's very new to developers, so how do they actually get started? So that's Stakehouse Academy, right? So we provide a set of templates, and we've shared for Stakehouse protocol. LSD is built on top of Stakehouse protocol, LP position on top of that, and we just release those contracts to people and say, well, look, so this is how the base works. These are the documentation, but if you want to see sort of in practice how to build on top, well, here's an example implementation, and you can go and fork and do whatever you want with it. We are, currently on testnet, we have KETH, that is a staked unit of account with a single target rate, regardless of any LST that's being deposited. So you can deposit your STETH, your RETH, DETH, and you'll get a staked unit with a target rate. Now, people looked at that, and within sort of 24 hours of being released, people were like, okay, well, I kind of understand this, and I'm going to build a strategy where I'm going to deposit into KETH, and I'm going to create this contract, and it's going to do ABC things. So people are definitely interested and curious, I think, on how to leverage the underlying yield being produced by validators. So validators on the inflation reward side of things are produce a fairly predictable yield as long as the validator is online, and that yield through Stakehouse, through KETH, is extremely programmable. One thing that we've previously thought about but haven't built it ourselves is how to leverage that programmable yield to do self-repaying loans. You can definitely combine that with compound staking, which is, so if you go to github.com/stakehouse-dev, there's a compound staking that was built by a community member, and that allows users to set up validators with 80 ETH and borrow the other 24 ETH that they need to set up the validators. You can combine that with KETH to actually skip the activation queue on the validators. It's currently like over 30 days at the time of speaking, so that's we're here mid-July, so there's 32 days activation. So you can jump the queue, earn yield, repay your loans. So this whole self-repaying loans is, not a new concept, but the source of the yield to pay those loans hasn't been sustainable. With validators, through the Stakehouse protocol, you can use that programmable yield to do some really interesting things. Validators in general have a cost base. Besides the staking required to set up a validator, which actually you can borrow now these days. So you can borrow the ETH required for staking a validator. So besides that, there is a machine somewhere that has to run one or many validators. There is a cost associated with running that machine. That cost is fairly fixed. Running a validator is not now in the proof of stake world is not incredibly an intensive operation. Like, you don't need a big machine, but the cost is there. It's fairly fixed, fairly predictable. So how do you leverage the machines that are needed to run a validator? How do you leverage that and offer that the economics, or offer the security that validators are providing to the Ethereum network? How do you offer that to other networks, other middlewares? And that's what Blockswap Cloud is. So Blockswap Cloud is saying, okay, well, there are these validators that are working for the consensus layer. The consensus layer is monitoring its performance. The consensus layer knows if a validator is online or not, and will apply the appropriate penalties. Most cases, an inactivity penalty. It is tracking, attestations, inclusion distance, block proposals, and that goes into the earnings of a validator. Now you can extrapolate that and use that to actually provide staking security for other networks and other middlewares. So Blockswap Cloud will provide that out of the box for any validator on the Ethereum network, and middleware software will derive liveness from the consensus layer validator. It will be able to detect corruption events, and from that be able to adjust the payments to validators. So validators will earn additional revenue streams. They'll have additional revenue streams for the same sort of cost base that they're used to already. But if any liveness or corruption is detected along the way, their earnings will be adjusted. And that is through like a smart contract suite. That is like a hybrid registry pool model. It will self-adjust. So generally speaking, users will earn some pro rata income. But, based on their performance, they may be eligible for sort of more premium services, maybe not. Validators now have a fear of loss of payment. So we want to completely strip that back. We want to say, you can look forward to continuous payouts every 7 days by doing certain activities working for the Ethereum consensus layer, but also working for additional networks. So that's Blockswap Cloud. But then barrier to entry is really high for validators. It sits, the stake amount is set at 32. So how do we reduce that? It's come down to 8, 4, and with the 0 ETH club, you won't need a cost. So you won't need to put up the cost of running a validator. You just need to put up, some small amount of money, and you just have to offer a machine. And that sort of falls down the line of sort of like financial inclusion. There's a lot of people who have machines and are willing to run validators, but don't have the upfront stake amount to run the validators. You get to a point where people can say, well, I have a machine, I'm a good guy, I'll run this, and you can monitor me, and if I don't perform well, you can slash my earnings, right? So they then create a revenue stream for themselves. They're building blocks for Ethereum, building blocks for other networks. This all powers a new network of applications. So you have programmable yield that produces protocols that are long lasting. So crypto in general has a problem. We have these booms and busts because nothing is really sustainable. Most projects are coming and going in 6 months, right? We need a foundation, a financial substrate where on top of which we can build long-lasting sustainable protocols on the yield of Ethereum validators. So as long as the chain keeps moving ahead, we will have that yield, and we'll be able to build a flourishing industry. And we need the validators to secure the network, and we need the users to be able to participate in the Ethereum economy without getting constantly wrecked. Wherever they go, they're getting sandwich, front run, back run. We need to, stop that. We need to build an open proposer, build a marketplace in an open MEV supply chain. And when we achieve that, we'll be in a much better place, and we'll be closer to the original vision, I hope, of Ethereum.